Okay, we're going to have a Chapter 3 exam in the next couple days, so you need to make sure we understand these questions. Okay, so in Chapter 3, we learned what a function is. Okay, so a function is just a set of inputs and outputs, but every input can only have one outcome. So this first part of this practice, we're looking at situations and we have to determine if it's a function or not. So when I just list individual points, all you have to do is look at the x values. So I have a 1, 2, 4, and 0. I did not repeat myself. Every input has one outcome. I don't care if all the outcomes are the same. Okay, I don't care if the outcomes repeat. All I care about, every input only has one outcome. So in this case, it's simply a yes. So this is a yes or no question. Okay, so then over here, -1, -2, 7, 0, -2. Notice -2 has an outcome of 86, and then later on, -2 has a totally different outcome. It's not a function. Okay? So then this, I have it, again, just written this way, just a slightly different way of writing this, but this is definitely a no, because right there, 5 has two different outcomes. That's clearly a no. 1, 2, 3, 4, 5, that is a yes. And again, it doesn't matter if all the outputs are the same. If you would graph these points, it would be a horizontal. All the points would be on the same level, but it would be a function. Okay? As far as a mapping, so if you see a mapping, you can clearly tell because right here, 0 is mapped to an outcome of -2, and then 0 is also mapped to a 1. That's your violation of a function, so it's a no. Okay? But here, every input, every x value, only has one mapping. Okay, so then this number 6 is a function. Okay, so hopefully so far, real easy just to be able to determine the different ways of being able to tell if we have a function or not. Now, as far as graphs, we just have to make sure there's no dot on top of a dot. It passes the vertical line test. So if I pass a vertical line, it should only be touching one point on the graph at a time. So in this case, it passes the vertical line test, and it is a function. Every input has only one outcome. Okay? So here, notice this is an open circle, that's a closed. So even though we have a dot on top of a dot, this dot doesn't count. Okay, so for the input of -2, there's only one outcome. So this would pass the vertical line test. So even with a point like 1, input of 1, the only outcome is 0. This 3 doesn't count because it's an open circle. So this is another graph that is a function. Okay, so again, if you would see a closed circle on top of a closed circle, if this was closed in, if I would close that in, then I would have to change my answer to a no. Okay, so now we also learned about domain and range. So in this case, I just have to list my inputs. So I'm just going to write down 1, 2, 4, and 0. That's my domain. Definition of range is our y values, our output. So in this case, I see a 3, 6, 11, and a 2. Okay. Most people on our quiz could easily list the domain and range. Same thing for this one. My domain are the inputs, my x values. I have 2, 3, 7, 8, 12. And then my range, my outcomes, I have an outcome of -3. You don't have to write it twice. You can just write it one time. I have an outcome of 0 and a +3. So that's all my outcomes. Okay. So here, your x's are your domain. Okay. We have a -2, +2, 4, 5, and 6. Very easy to list the inputs. My range, the y values, 4, 16, 25, 36. Okay, so again, don't get those wrong. Okay, so now here's where some people struggle when it's a continuous graph. Okay, so to be able to state all the inputs you have to use an inequality, okay? So we look here, this input is a closed circle, and it has an input of -5. So my smallest x value is going to be a -5. So I need to let someone know my inputs are greater or equal to -5. So we want to include this and include all the decimals, every single input up until we get to another closed circle, and it's at 8. So we're going to put my input in between the smallest and the largest input that I see on my graph, okay? That includes 3.1. You would have an outcome of 3/4. So you need to include all the decimals, all the fractions, everything in between. As far as the range is concerned, start with the lowest outcome. So it looks like my lowest outcome, this dot right here, is at the bottom, and it's at -9. So I want to put y in the middle. We want to say all our outcomes are greater or equal to -9, and they go to the highest point, which looks like a y value of -2. Okay, so if this was money, you never had any positive. It's always negative outcomes. When you look at this graph, they're all below the x-axis. But as far as the largest outcome, it's going to be a -2. So don't allow your brain to confuse you with inputs and outputs. So when I'm looking at this dot, and for the range, I'm looking at the outcome is 2 blocks down below the x-axis. So that's how we write inequalities, so that we can get all the points in between. Okay, it would be impossible to list all of them individually because of all the decimals and fractions. Okay, so that takes care of page 1. Page 2, we're going to continue to state the domain and the range. So as far as my domain for this problem, I have an open circle at -4. Okay, but now notice there's an arrow. So I'm not going to be able to put my pen at a stopping point for the domain. We have a starting point, so all you have to do is say your domain, so I'll write domain, our inputs, so x values are going to be greater than -4. That would describe to someone that graph, that smallest input is a -4, but then all the other inputs, like 10 would be an input, because that graph continues to go up forever. As far as the range, so range, my y values, once again, I'm going to have an inequality where the lowest outcome is a -1, but not equal to -1. Since it's an open circle, same thing with input. I don't want to put a line. We're not equal to -4. We have to be greater than -4, and our outcomes would have to be greater than -1. Okay, so again, force yourself to understand. We're looking at this point. For the x's, we look at the x value. For the range, we look at the y value. Okay, for this one, again, this goes up forever. Okay, so my domain, I need you to realize there for the x's, so change your focus. There's no starting point, or there's no lowest x value. It goes forever. So if I go so far over here, -1,000,000, I can plug in. So this graph goes in both directions, and so you're just going to say all real numbers, or simply all numbers. Okay, we don't know about imaginary numbers yet, so we're dealing with every single input you can think of. Okay, but now the range, though, it doesn't point down. So as far as your outcomes, your y values are always going to be greater or equal to 0. So we do have an outcome. The lowest outcome is at 0. All the other dots are going to be above it. So 0 and above is the range. Easiest way to state that is using inequality. Okay, so now this line right here goes on forever in both directions. So again, no starting and stopping point for your inputs, so it's all real numbers. Okay, and then range, there's no smallest because it goes down forever. There's no highest outcome because it goes forever. So once again, all real numbers. Okay, so again, make sense to your brain. For this graph, I do have a starting point for my x's. Okay, so all my inputs are going to be 0 and above. They're all on this side of the y-axis. So my domain is going to be x values greater or equal to 0. Okay? Now, as far as the range, there is no point I can put as the lowest because this graph continues to go down forever. So it's going to continue to go down forever, and it's going to continue to go up forever. So in this case, the range, your y values, are every real number. So all real numbers. 1,000,000 would be an outcome eventually if you continue that graph onward. Okay? Now for this one, we just have individual dots. So this is what's known as a discrete graph, not a continuous graph. So we have to list the individual inputs. So for my domain, I have an input of 1, 2, 3, 4, 5, and the last dot is a 6. Okay? As far as the outcomes, your range, we'll start here. Down here, we do have a negative outcome of -1. We have an outcome of 0. This dot has an outcome of 1. This dot has an outcome of 2. We have an outcome of 3. And then we jump all the way up to an outcome of 6. Okay? And again, understand a domain and range. If you ever go in Algebra 2, go beyond that. It is very important to understand what your inputs and outputs are for a certain situation. Okay? Next page. This notation, this is simply asking us, when you see a function, f of x, this is your outcomes. This means the outcomes. I have half of a number minus 8. Well, I want my input to be a 14. So that's our universal way of letting someone know, hey, get the answer. So f of 14 is really half of 14 minus 8. Okay, so my answer, so f of 14 is going to be 7 minus 8. I'll even write that, which just simply gives us a -1. That's our answer, okay? We're not solving for f. The outcome is -1 given the input of 14. So you just have to get used to that notation. So g of 10, we are simply replacing the x with a 10. And if you need a calculator, don't get these calculations wrong. -5 times a 10 and then minus 10. It's going to be a -60. Okay? For this one, we're taking a third of 12. So a third of 12 minus 2. If you need a calculator, I know the answer is going to be a 2, but remember, fractions simply go in parentheses. 1 divided by 3, then I can multiply by 12 minus 2. The calculator knows that this will be a 4. 4 minus 2 is simply a 2. Okay, so if you can do those calculations in your head, great, but just don't get them wrong. Now, be careful, that's a half, so it's negative 0.5 times 36 plus 12. Okay, so negative 0.5, so a half of 36 is going to be 18, and then 18 plus 12, we should get a -6, because negative 18 plus 12, which is a -6. Okay, so super easy to replace an x with whatever value I have. Now this part, a lot of people mess this up on their quiz. This is different. This notation is telling you the outcome. We want to solve for x. Okay, so we are going to solve an equation like we did in chapter 1. But this time, my outcome is -4, so show this work. So show the equation you're going to solve. And then 2 steps and we have the answer. So my first step, I'm going to add a 3. I get -1. And then my last step, I'm either going to divide by a half or multiply by 2. So x is going to be a -2. So I'll show that on the calculator. So if you know you have to divide by a half, I can type it that way or simply divide by 0.5, but I know it's going to give me an answer -2. Okay, so you would plug a -2 back into your rule, Half of -2 is -1. -1 minus 3 is this outcome. So this is the outcome. We are solving for the input. Okay, so just make sure you understand that when you see this on a test. So -5 is my outcome. Mr. Wegman gave you another fraction, but we don't care because the calculator can help us. We subtract 7, you get a -12. And then we're going to divide by -4/5 on both sides. So x equals, our answer is going to be a -12 divided by, remember the parentheses if you have to deal with a fraction, and you're going to get a nice answer of 15. Okay? And how you can check, so if that's my input, I should be able to go back to my original rule where it's -4/5 times my input and add 7, and this better be -5. And it is. Okay, so our input gives us the output. Okay, 2 more of these. We have 38 equals -4 plus 7x. We're going to have to add a 4. So when we add a 4, you're going to get 42. And then our last move is to divide by 7. And you get a nice answer of 6. And again, if this was a test, it doesn't take long to just check. Just check to see if your input will give you the output that was originally given. Okay, so we're solving for inputs. This one, -9 equals -5x plus 1. We have to subtract a 1. We get -10. And then we divide by -5. And we get a 2. Okay, again, real easy. -5 times 2 is -10. -10 plus 1 gives us that -9. Okay, so expect a couple problems like that, just like it was on your quiz. Now we shift gears. These are in standard form. I'm just asking you, show me the steps to solve for y. Okay, to rewrite this in slope-intercept form, which is y equals mx plus b. So I want to transform these equations into y equals mx plus b, which should be pretty easy. I have to remove this 3x by subtracting a 3x. Just send it over to the other side. And then we divide everything by 2. And then you can clean this up. The slope would be down 3 over 2. That's your slope, the number in front of your x. And your starting point would be a 4. Okay? For this one, just be careful of signs. My first move is to add an x. So to get this negative x over to the other side, I have to add it. So it's a positive x now. And then I'm going to divide everything by -3. Okay, now remember, there's a 1 here. So you should know that the slope of this is down 1 over 3. So it's going to be going downhill at a rate of down 1 over 3. And we're starting out 9 divided by -3. We're starting out at -3. Okay, so again, that skill to be able to solve for y, very important for what we're going to be doing later. So now, graphing, I have 8 graphs here. This should only take a matter of seconds to graph, okay, especially when it's already in slope-intercept form. So I have slope-intercept form. Some of you had this backwards. This right here is your y-intercept. So B is the y-intercept. So what that means is where your line would be crossing the y-axis. Okay, there's the y-axis. It starts at -2. Now, normally I would count down 7 and over 5. I don't have quite enough room to count down 7, so I can count up 7. 1, 2, 3, 4, 5, 6, 7, and then to the left, 1, 2, 3, 4, 5. My line must be going downhill. Okay, that is so important for you to understand that the line must go downhill when it's a negative slope. Where this line starts at 3 and it's going uphill at a rate of up to over 1, 2, 3, 4, 5. Okay, graphing a line needs to be easy for everybody. There should be no one, you can count, you can graph a line. Okay, here, this situation, we start at -3. That is my starting amount. And once again, we're spending too much money. I don't have enough room to count down 8 and over 1. It will be a steep line going downhill, so I'm going to count up 8. So I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, and go over to the left one, which is a steep line. Again, it's okay to count off your paper, but I like using the space provided. Okay? Now, I threw you a curveball here because this is a unique problem where it's just telling you x is -1. So when you see just x in a number, it is a vertical line. And remember, the slope of a vertical line is undefined. There is no slope for a vertical line. So the other special type of line is just when it's y equals, and then it would be a flat line. Okay, so those problems should be very easy for you to understand, and everybody should agree. And then this next part, 2 ways of doing these. My suggestion is just solve for y. To do what we did earlier on this review, where take the time to get rid of the x, send the x over to the other side, and in this case, we have to divide everything by -1. Okay, so when we do that, we're left with positive 2x, or negative over negative is positive, plus 5. So I know I have a starting point of 5. I'm going up 2 over 1. Yes, you can go off your paper, but I can also go down 2 over 1. Okay? So I'm going to try to draw a straight line. There it is. That's the best I can do for a straight line. And just realize if you cover up the y and solve for x, you're going to see the x-intercept. So if I cover up this y here, that's how you can also check your line. When I divide by 2, I get negative 2.5. That line is crossing the x-axis at negative 2.5. Okay, the y-intercept is a positive. If I cover up the x term, solve for y, I get the y-intercept of positive 5. So this time, I'll just do that. I'll cover up the y term, and I see nothing to solve. I see x is negative 6. So I know this line will cross the x-axis at negative 6. If I cover up the x term and solve, I know it's crossing at 3. Okay? So there's my line, but I'll also show you this way, just to show that we have the same line. So if you solve for y, you're going to see that the slope is a positive 1/2. 2 negatives make a positive. There is a 1 right there. And then we get a plus 3. So I need to squeeze my x in there. So up 1 over 2. Notice it's all the same line. Okay? So x-intercepts are nice. For this one, if I cover up the x, I'm going to know that I'm going to have a y-intercept of negative 3. And I also know that if I solve this, 3 divided by 2 is 1.5. So I will know that it's going to go through the x-axis at 1.5, but I'll also show this way. I'll subtract my 2x, and I'm going to divide everything by negative 1. And I see that I have a slope of 2. So I'm going up 2 over 1. Draw my line, and it all matches. It all fits. It has to fit. Okay? So here, cover up the y. I know it's going to be crossing the x-axis over here at 7.5. So it's going to be crossing somewhere over here, and I know my y-intercept is going to be 15 divided by 5, which is a 3. Okay? So I know my line is going to go down like this, but let's show that by solving for y. I subtract my 2x. And I divide everything by 5. So this line is down 2 over 5, starting at 3. So if I go down 2 over 1, 2, 3, 4, 5, connect my dots, I will see that it will cross the x-axis at 7.5. So the x-intercept is 15 divided by 2, which is about 7.5. Okay? So that review took 25 minutes to explain. You need to make sure you can do these problems. Our exam, which will be worth 100 points, your quiz was just a couple points. This is going to be a percentage. So since it is a Chapter 3 exam, you need to make sure you understand this context and ask for help. Make sure you get all these correct answers. If you need more practice, let me know. Go back and look at our online assignments, and all this should make sense to you. Thanks for watching. Take care.